Hmm. Hey everybody, doing another Leetcode Weekly Contest 162. There's about 50 seconds left. Wish me luck. Hope everyone's having a good week or weekend or whenever you're watching it. Just having a good time. Hope you're having a good time. Uh, but yeah, I'll probably want a commentary. So you'll see another Larry below or something. But we'll see. I mean, if it goes well. If not, then it might take way too long, then maybe I don't know. All right. The contest will start in about 20 seconds. So I usually code very quietly and deep in dot and stuff. So I should get my paper ready. So but yeah, for my counterpart, we'll do a bit of talking. So don't worry. Cool. All right. 3, 2, 1, blast off. Cool. So as usual, I open all four problems at the beginning. So that way, while I'm reading the first problem, everything will be loading. I think I should learn that from Eric Toll. I don't know if I'm saying his name right, but yeah. For this one, I think as soon as I saw it, I was like, oh, okay, it must be simulation because I look at the constraints. I think right here, I look at the constraints. I'm okay. It's you just do simulation. Actually, at this point, to be honest, I thought it just when you press a button, it actually only looks at the adjacent ones, not necessarily the not the entire row or column that was selected. But I actually come back to look at it, and I actually went back and forth between Python and C++. I think I was just really bad for, to be honest, on what you might call it, on getting. I forgot the syntax. I was like, I don't want to waste time on looking up the syntax, right? So I should be more practiced on this, to be honest. But that's what I was going back and forth. I'm like C++. Okay, I'll just do a C++. I'll just create, a cell, enough cells, and then I would just simulate it. I think looking, and this is for n times m is 50 times 50 square. I think right about now I look at the problem again to I initialize it, but right about now I'm looking at the problem again and be like, oh, it's not just adjacent. You have to do the entire row, the entire column. You'll see me scroll up for a little bit, and that's when I do that. But yeah, but overall, easy-ish simulation problem because you look at the constraint first, and that's how I kind of went to attack it. But some of this I could actually clean up in. I should probably clean up a little bit on like using auto, for example, in the for loop. But I think one thing to kind of note is actually, yeah. I think if n and m is bigger than 50, I think there's actually like a cute keeping track of each just row and column type thing, and then maybe do some math on the parity. But for this, when you see that n and m is small, then it's unnecessary. And yeah, you saw me kind of see, oh, it's not actually just next to it. It's rows and columns. I think the thing that I did here was also just make sure that I got the right row and the right column. Because one thing that is very common for me is that sometimes I swap the indices. So I was like, am I right? Not just on the cell usage, but also sometimes on like the constraints, right, between the n and the m's. And here I do change. That's the risk of copy and pasting is that when you copy and paste, you fix one place but not in the other place. Sometimes I mean, it's a coin flip, but sometimes I just actually type out the second instead of copy and paste so that I force myself to know what I'm writing. Here I'm just counting the number of odd numbers. This is pretty standard. And then, yeah, I mean, I think right now I'm confident-ish that I could submit and get it right, but I just wanted to, I don't know. I mean, I think if you get it, if there's a silly typo, it's 5 minutes, right? And I've been victim of that a lot recently, so I've tried to at least test the example for something silly. I mean, overall, like a minute here and there, like I'm not contending to be number one, so it's okay. Uh, cool. And I was just like, I'm still relatively confident. Just a couple of full loops, right? So I'm done. Woohoo! Problem two. Um, this was a tricky one. My first instinct about thinking n columns and two or n by two matrices is maybe some kind of dynamic programming. To be honest, there are a lot of counting problems that kind of start with that premise, so that's where my mind went. But I actually continue reading the problem. First is that there's a binary matrix, which means they're going to be 0 and 1, and then you're given an upper and lower. That's when right now I look at the paper. I took some notes on a paper to kind of see, to visualize what it means. What are the inputs, right? Because the inputs are kind of a little abstract. They don't really give an example of this. I wish they did a little bit. I mean, it's not that hard to give an example, and probably won't show anything or give anything away. But as soon as I drew it out, I was able to kind of figure out that, and look at constraints a little bit, that greedy is probably the way to go because it is binary. For the only times you make a decision is when you have one in the car somewhere. Because if it's 2 or 0 or 0 or 2, 0 means for that column it's going to be both zeros, and it's 2, they're both ones, right? There's no decision there. And then after you resolve that, I think that's mostly it. That's the way I kind of thought about it. And then after that is greedy because, well, you don't matter. If it doesn't matter which answer you return, then just return the one that favors the upper. In my case, upper. I just put everything on upper if there's any, and then lower if I have anything left over. But not a big deal. I mean, you could go the other way. Obviously, it doesn't really matter because it accepts multiple answers. But right here, what I try to do like a sort of like a counting sort type thing actually, and then I changed my mind. I was like, well, actually, I don't even need to do counting sort. I can maybe just go through the column sum and then do it greedily in one pass. I was a little bit wrong actually, as you could kind of see, or you will see in a little bit. Yeah, so here I was like, okay, if x is equal to 2, then both of them has to be 1, and then we kind of keep track of it by subtracting it from lower and upper and lower, or decrement them. One thing to note actually is that upper plus lower should be equal to cos sum, the sum of the because there are just two ways to count the number of ones in the entire matrix in general. So you could actually have a easier way to show that, or like to terminate early. I end up just actually, I didn't think about this during the contest. So, but here as well, as I was saying, if x is 2, you force 2 ones. If x is 0, you force 2 zeros. Otherwise, just do greedy, right? And putting the answer in the right place. So this is roughly about 8 minutes in. So I probably could have saved a few minutes if I could submit here. And then I did some bound checking, or upper lower checking. Initially, I thought if it's negative, then we return. But actually, we have leftovers. We also want to return 0. So this turns out to be wrong actually, because I did in one pass. And what happens is that if you do it in one pass, and good thing I kind of add the test stuff. But yeah, right here, and you'll see this in a second, where I put in the test, I run it, and then it gives me, I think, a invalid or like uncreatable thing on the third test case. I was like, that's not right. And then I look up and I was like, okay, why could that not be constructible? And the reason that is the case, a scenario in which that is the case, is when you, because I greedily take from the upper first, then the lower. If there are two, if a number 2 comes up, then I need to take from both. But if you went off upper because you took it greedily, then it doesn't happen. I think now that I think about it while I'm commentating, commutating. You could probably still do it a little bit smartly if you do like greedily take the lower of upper and lower. But I think that's, but I think for me, it's okay to do it in 2 pass. That was my thought, and I was relatively confident that I could do it in 2 pass, and that it would be the right answer. Um, yeah. Basically taking the 2 and the zeros first, and then afterwards do another pass on the ones, on the card sum. See if you could spot the typo here, because this typo cost me maybe 2 minutes, which is not at my level, not a big deal. But anytime I'm looking backwards, I'm like, well, where could I have saved time, right? And in this case, it's only when it's lower than 0, because obviously it should be greater than 0 generally. Well, okay, I'll tell you. The first typo here is that I still use append. But the other is that, yeah, the 2 typos here. One is that I use append. Let's say I fixed all the appends, because I actually looked at the wrong one. But yeah, I was going to print out like some stuff, but then I immediately realized that I was using append. So that, I mean, it's just silly mistakes. But there is still one typo here. See if you can spot it. I would say, as a result of all these edits, I did have a little lower confidence in this problem, like submitting correct in the first try, just because I made, I think when you tend to rush, when you do minor, quote unquote, minor edits, you tend to rush a little bit, and you're like, but sometimes your assumed invariants change, and your invariants are not invariant anymore, and they vary. And that's when you get silly mistakes. So as a result of that experience, I was yeah not yeah not super confident about this problem. But right here, right now, I was like, well, this is giving me an index out of bounds or a y, and it's the same, maybe a little bit of foreshadowing from the first problem, is that I swapped the x and the y's. So again, I made this another minor quote unquote minor fix, and hope that I don't have any typos, which is definitely a possible thing, and or change invariance. But this one shouldn't change any invariance. So that looked good. So I submitted, and well, I think I double checked. Oh, I had to, because the result was long, so I had to go up and make sure that it was right. And as soon as I got accepted, silly mistakes, but overall not too bad. Yeah, so number of coast islands. So I do talk about this later in the retro, and I'll get right back into this when I actually end up skipping this problem in, I don't know how long, but very soon. So I will get back to talking about my film here. But generally, my thing here was that, man, I know that it's going to be some kind of flood fill, and flood fills for me, they're always off by one, and I had trouble understanding the example, so I skipped ahead for a little bit, just to take a look at the last problem. So the last problem, I look at the score, I look at the words, I look at the letters I mean, those are the inputs, not just like me reading the problem. And immediately I thought it's something similar to, say, the Scrabble, the game. And how would I solve this? Well, I think the way I would go about it is some sort of dynamic programming based on what words I used. But I had, to be honest, I kind of have some commingling of ideas here. First thing I noticed is that n is 14. When n is 14, it means that you can do some kind of 2 to the n thing, possibly. Yeah, you can't do n factorial stuff, but in that case, that doesn't make sense. Right here, I jump back, I think, just to see if maybe I have an easier way of doing it. But I'm like, but I think in the back of my mind, I was, well, I have issues reading this problem particularly for a reason that I'll get into in a second. But when I go back to solving this problem, but I'm still at that point deciding between that one and here. I'm like, well, n is 14. It's gonna be 2 to the n. Let me just code this up. That's what I was doing. I was initially going for some kind of dynamic programming type approach, but it didn't actually really make sense the way I was going about it necessarily. But it's just that I'm using one of the templates that, I mean, not templates, but like you know, like like a mental template of similar problems and how I would solve them, and kind of type them up while I still really concretely formulate how I want to attack this problem. Um, Here I type out the dynamic programming template, uh, and I use the word template because you know, at this point I probably solved this, not this, but like if this is this type of dynamic program problem that I've solved probably like hundreds of times, right? So I have I have muscle memory of how to kind of go about it. But then I think here I'm having second thoughts of like, do I really need the dynamic programming? And I do come to a conclusion in a couple minutes. So maybe you could argue that I spent 5 minutes doing like going back and forth on how to approach this problem. Yeah, right here I'm already having second doubts. But I'm just trying to power it through even that doubts. Um, because I don't, because here I really didn't think. I mean, this one it was tractable, right? Like I knew I could solve it. It's just about which way and which way is quicker. I think right about here, I was thinking that if I do some kind of like recursion thing, uh, it'll be faster because you kind of already chop off the branches. You know, like it's like a natural branch and bound type thing where you already root out the impossible things. Um, yeah, the impossible things, right? Um, and here I probably could have used an array of 26 characters and just increment it, but instead I used an unordered map because I didn't want to think about it that much. Um, Not a big deal either way. It's all of 26, right? It's constant. Um, but yeah, I think my mind was stuck between two problems right here, which is something that kind of add a couple of minutes to my end time. Here again, these are kind of standard-ish dynamic programming template. Oh yeah, so here and that's where language unfamiliarity kind of plays here. I forgot. I wasn't sure if you could do m sub x plus or equals 1 in the sense that like if x is not in the unordered map, does it throw an error or something like that? In some languages it does. I wasn't sure if it does in C++ and clearly because I was trying to find it to see if there's an exception or type thing and it didn't. So I knew I was good there. Here I'm just really this is very standard dynamic programming, though that's not how I end up solving it. Spoiler alert. But I mean, I go on for a couple more minutes, which I mean, I can totally understand why what the top people or how the top people got so fast because this is not that like I mean I pivot from what I have now to the future like very quickly, so almost scarily quickly, but like so this is about 19 minutes in. I submitted at 25 minutes ish. So the crazy thing is that like I deleted most of what I have now and then be able to solve in 6 minutes. Of course, the hard part is always going to be figure out the algorithm, the typing, and the coding. I mean, it matters, but at least not for this problem, because sometimes there are some problems where the tricky part comes from the coding. Um, but and some of that comes from experience. You know, you have to, yeah. And I think I'm like, actually, I don't need this. I don't need a lot of these. So let me delete and then start over. Um, Basically, I use a bitmask way of doing a power set, but this is essentially a power set. You could do this recursively, and a lot of people do. Um, but I generally don't find it necessary. I don't even. Oh, I did need this, I think, actually, but I just didn't want to write clear that clear. I don't even know why that was named cleared, actually. Now that I think about it, but. And this is very straightforward. I mean, not straightforward, but standard-ish way in competitive programming to do power set. Though there are definitely ways, but this is the way you would do it if you didn't care about um, kind of the constant time, because in theory, you want to do recursively because in some cases because recursion allow you to kind of like chop off branches, which buys you very good performance in some cases, depending on how the constraint is set out. Um, but yeah, here I was like, but I could actually get even smarter a little bit with iterators. So I am learning a little bit. Though I think at that point I don't know if I saved that much time, but it does make the code a lot easier to read. Um, yeah, and then but I'm like, oh, I have to keep track of this, whether this is a good word. Um, so yeah, initially I do it to file, and then yeah, I track if I was debating doing this at the end after you tally all the things, but I was like, oh, actually, I don't really need to. I mean, you could do it at the end. I mean, it doesn't really matter because, well, I think this was actually slower to be honest because it goes for each character instead of just doing 26 characters every 20. You know, so it's instead of O of 26, it's like O of n-ish, but where n is the total number of characters, but it's not a big deal. Uh, Here I just keep track of score, and that's when I realized that I have a bad variable name. um, I have to convert the character k to index, and then there you go. And then after all, you just set the best score to whatever's higher. Kind of. Spot the typo. Well, there's a couple. One is that yeah, I used the wrong variable name, but spot the typo again. There's one more typo, so I could have done a little bit faster. But even with the typo, so that took about 3-4 minutes to type. Effectively, I'm almost done. And then the code is so tight, and what I mean is that it's just very concise and maybe precise. That like, oh, there's actually 2 typos. Wow, I forgot about this other typo actually. But yeah, so spot the typo, but. So there you go. There's one. There's one more typo. But that's actually kind of like look retrospectively a little bad that there's so many typos. But the and I was just talking about keeping the code tight and stuff, right? But yeah, now that the code is small, you know that they're not. That's the good thing about keeping the code small, right? Is that it does allow you to look at all your code and be like, oh, this is very short, small code. There are not that many places to make errors and typos and so forth. So here I'm just typing in all the test cases, and I would say I do respect this being hard difficulty that I might as well that but here I spotted the answers 43. I'm like, how do you get 43? And that's where the typo is. I think right here, even before I looked at the, I don't know, did I look at the answer? I think before I looked at the answer, I noticed the issue. Oh, I don't know why there's a, well, I mean, I noticed the issue before I looked at the solution is that I don't use found, which is, so that's why I, you know, always have an answer. And here I didn't look at the results, but I just look at 22 and 27, which is the right answer. So then I could point it out. And the two things to test, one is that, especially for hard problem, I'm like, you know, a silly mistake will cost you 5 minutes. I'm just like, okay, just put in a test, right? And I think here, I have one more test to type, which is the 14 case, which I probably do. Like with n is equal to 14. And the way I wrote my code, it doesn't matter, like I don't do anything smart to filter, so I could duplicate part of the input and still, as long as I get 14 words, it's good enough. Though I do note that, you know, the characters are not long enough, so in theory it could be slightly slower, but I saw that it was 73 millisecond given these examples. I was like, okay, that's good enough. Accept it, let's go to here. Yeah, here I'm looking at the I'm like, wow, someone finished all the problems in 13 minutes. And I am 26 minutes in-ish. I have to figure out this problem. It's doable. People have done it in, you know, very quickly. I didn't really look at the score. Sometimes I look at the score for hints on like how to, like an estimation on difficulty. But I was like, okay, you just have to do this. Focus. And I think the biggest problem for me here, and it took me a long time to understand this problem because conventionally, on these kind of flood fills, 0 is the water and 1 is the land. So I was like, oh, okay, I did check then. That people did it very quickly. But yeah, traditionally, yeah, 0 is the water and 1 is the land. And here the problem is inverted. So yeah, it took me a longer time to understand. But yeah, what I do here was I was going to copy over the grid to another grid, and then surround the grid with an like a border, if you will, so that it makes certain things easier. I was going to go with something from the like. Here I was thinking that I could do some flood fill from the outside. Hey, if a flood fill from the outside could get to the ins. I was gonna do something clever where like the invariant is that if you're on the you start on the border and you flood fill the border, and it would fill all the stuff, all the zeros that are already on the outside, so that you only get the islands after that counting. But then, as I was coding this, I was like, man, that's at the time I thought there may be some like more nuance and trickiness. So I end up scrapping this in maybe in a minute or so. Because I thought like, man, now I'm playing too much with weirdness. Actually turned out not to be the case now that I think about it now. But I think I was just like trying to do the safe thing, even though it didn't really turn out to be that safe, to be honest. Because I was still doing a little bit of sketch because I didn't really. I think at this problem is because it's so close to like a typical problem that I like had templates on how you do, you know, depth first search and flood fill depth first search specifically. Like I've done that probably hundreds of times, right? So I was trying to like, while I'm typing, merge that idea with kind of the variant on this problem, which is maybe the border issue. Yeah. Yeah, but then I think eventually I was just like, yeah, it's okay. Maybe I don't need it. And then in this case, if I don't need the border, do I still need the grid? And the count thing is just template, so it's not a big deal. Here are my globals, not recommended on interviews, but for this problem, maybe it's okay. And here again, I'm a little wary about the N and M's. I get them mixed a lot. No, I didn't need it. I was just thinking whether I should put it in another way or just do it inside the grid itself, which I end up using the grid itself. The found is like a really bad variable name here. It's just whether it's more like whether this recursion is good. in that it's almost the inverse of what it should name, which is that if it didn't find outside error, you add the count. And then now we do the recursion. I actually put in the. I was debating putting the grid in global, but I was like, it's fine. It's not a big deal. I just put, I just pass in the reference. Forgot to declare the NMs. And I do a very basic check. Also, I'm not using C++ syntax here, but yeah, I didn't even realize I had that much typos. There is something to be said about like just being practiced, right? Because then you wouldn't do stuff like this because you forget. And that's just about really learning your tools. Right here, I know that it was a void, but I just wanted to see whether I have any like weird compiling issues, especially with the DXD right away. So after this, it's in theory easy, but I still took a little bit of time. I'm taking like 5-6 minutes on this part, which is actually something that maybe I could have cut off, but I haven't practiced this in a long time. So, but yeah, I was trying to also use using grid as a kind of like a scene way, because you never need to see a one anyway. And here this part was good. Spot the typo. You could buy very quickly. That actually cost me maybe like a minute. And well, spot 2 typos actually. Now that I see it, I mean I do correct them obviously because spoiler alert, I do solve this problem, but it's a little sad to see retrospect. I should have bound checked here as well. I should have checked a little bit over there, but I thought that maybe I could be clever enough about it. And here I get an overflow for a reason that you see. It was sad. I was like, did I do something? I guess I end up spending like 2 minutes debugging this, which is a little sad for a standard-ish problem. And I thought that there may be some like nuance that I didn't think about and that I need to explicitly create a scene away. It's turned out to be the wrong approach, but at the time I thought maybe I just have to, but I think, yeah. I had some weird responses actually. And I think it's not that this, I mean, I think this is fixable. It's just that I was trying to do too much with this actually. So that was a detour that took. Oh, I did fix it. Oh, I didn't. I fixed that, but I didn't fix. I need to. I guess actually, now that I look at it, I remember I ran into something that I couldn't fix. But it's because I didn't initialize scene, so that's why it's giving me the wrong answer probably. In the overall the caller function. Here I have Stack Overflow, or I thought it was Stack Overflow to be honest. It wasn't actually a Stack Overflow, it was a buffer overflow, which means it's an index out of bounds actually. But if I had, and that's also something that like you have to learn your tools, right? If I had noticed that, then I would have likely looked at all my indexes. Here I just wanted to make sure that is it the recursion. I even put in XY, so adds even more times wasted on this. So there are definitely a lot of places of improvement for me this contest, which is good to know because I mean, you rather have a lot of when I was ahead with the last poem, so I could have maybe finished it if I finished it quickly enough. This quickly enough, I could have been higher. Maybe first page, top 25, but still getting better. Hopefully. Well, one is that was a return instead of doing the next one, so it skips ahead. So there's some like weirdness there, and it's still a one time error. And here I finally after the print, I do get a sense of what the issue is. I think hopefully soon. Well, that I did fix, so that was good. So that's great. So I put in more things, but because I never actually now that I mean I didn't know that at the time, and I actually
Why did they give us an informant
oh
like
yeah,
this?
and there are a lot of spaces, and I was wondering why I had to clear all the spaces for this poem, which added like 20 seconds. But yeah, but for this poem, I probably could have almost solved this just like this, except for except for I don't initialize the scene away, and that was the one of and yeah. I mean, I didn't actually need it, but that I couldn't figure it out in the next minute or so. Yeah, and because that like states get carried over, and I was like 10. How did I get 10? Could not understand it. Mhm. I mean, this makes it better, but it's still not sufficient. I still get a wrong answer as a result of using not initializing the scene away, and I actually never figured that out. 7 is a weird answer, right? I mean, and I just didn't know it was a stateless thing because otherwise, and I was like, oh, this is closer, but maybe I just don't need the scene away altogether. Uh, and I'm just trying to see like where. And then one time, it didn't actually. I mean, I was actually just removed it just because it was like I didn't need it any. I wasn't using it, but but after I changed that, I was like, oh, this answer is actually right. All right, but this is the last poem. I have didn't want to waste the wrong answer, so I just wanted to. Well, one, I was like, huh, I didn't realize that I mean, I didn't in the moment realize that changing the scene away fixed the thing. It's just that because yeah, but I just want to double check because clearly there's something wonky here. And I was just printing out even more debugging so that I could kind of see where it considers a fresh island. And after that, it was off to the races. And I think I'm done. So I think the other lab we will start talking in way soon. Bye, friends. Whew. I could have done faster, but took too long on the last one. Is this not updating or just yeah? Because I'm probably like 77th maybe. I was doing very well in time, but oh, there we go. But okay. Whew, sorry, give me a second to kind of catch up. I feel like I knew how to do all of these, and that's kind of the stressful part is trying to get them out really fast, and in the time that I took to do all 4, they got in one. But yeah, these people are very good, obviously. But I think some of that is just okay. I mean, let me go through the problems first, and then I'll go through like my personal thought process. Okay, so yeah, so this one is just simulation. I don't think there's anything about it. People did it really fast actually, but I was trying to avoid because I think one thing personally is just that I'm avoid trying to make stupid mistakes. So I will take a little bit more time just to make sure I don't get a submit error. It doesn't happen all the time. But yeah, but for this one, I think the tricky thing for me personally is just making sure that I got the indices right because I may confuse like the x and the y's. But in general, you just simulate it, given a position, just simulate it. I mean, maybe you could have done if the constraints are bigger, maybe you could do something. Maybe you need to do something smarter to kind of keep parity and stuff like this. But for this problem, there's no reason to. So just brute force, run it through this, and m is 50, so it's just 50, 50 cubed, with and square space. So yeah, so this is a pretty straightforward one. It is a easy. So it wasn't like the last easy where it took 40 minutes. Like two-row binary matrix. Yeah, I mean, this for me, this is just greedy. Did I do it by fun? Yeah. How long did I end up taking on this one? 9 minutes. Yeah, and a lot of those minutes were just me kind of not being precise with my coding. Like I mean, you saw it twice where well, I did actually have a problem initially where I thought I could just do it in one pass, but I was like, maybe you could do some math to do it in one pass, but let's just do it in two pass. And then, but the idea behind here is greedy because, well, because they're only binary, so there are only a few things you can do, which is that, well, if you get a two, then you know that well, it has to be both ones, and if we get a zero, then you know that both of them to be zero. And then now, if you have any left over, it could either be in either places, right? It doesn't matter because that means that all the rest of the inputs will be ones that you haven't gone through yet. And if they're all ones, then it doesn't matter whether they're like on the upper or the bottom, right? Because you have and they should match and so forth. But yeah, greedy is the reason there, and you're just kind of forced into picking them. I mean, at least for one solution. There could be multiple solutions, obviously, even in the examples. But yeah, greedy is the second one, and I think I did. I mean, other than the silliness, I did get down very quickly. Co-silence, I just have trouble reading this one, so I skipped ahead a little bit. And on this one, I think the first thing I note, I mean, it's like essentially like kind of like a Scrabble type thing. You have some letters that are worth X points. How of all the words, what can you do? So yeah, so the first thing I would look for, and these is kind of like the constraints. It's 14, so I used the calculator, 2 to 14 times 15, and that was like under a million, or like 250 or something like that, 250,000 that is. So I was like, okay, it's good enough. I was trying to maybe do some DP things I could like, so just in case it was doing in running time, but then I was like, let's just get it out. If I get a running time or a time limit, I get a time limited. But yeah, but I cranked this out, I think in 10 minutes ish, 12 minutes, 13 minutes. I probably could have done this faster because we look at this code, it's pretty straightforward. It was my first instinct, but I did want it to save some. It took me a little bit of time to be like, nah, you probably could get away with this, which is always a tricky skill. I think I put in a n is equal to 14 case, and it took like 73 milliseconds. So that's when I was like, okay, that was silly that I went the other way. I mean, I did obviously use some cache, like I did do things in a slick order, I would say. I mean, not that clever, just like more clever than naive, which is that I keep track of the number of letters, I keep track of the running score and the running tally, and check to see. So yeah, so that's kind of what I did here. So brute force in a smart-ish way, where you notice that it's 14, so it's just 2 to the 14 times 15. And that's it, and then just score it up. I think that's roughly right. I don't use any extra space. I mean, O of 26 space, which is constant space. But yeah, and I could use obviously I could have also used in a way, but that's fine. Number Coast Islands is just a relatively standard depth first search, but I think for me, to be honest, when I first read this, I was trying to read too fast, try to rush my a little bit because I thought I was doing well on time. Um, and I think I confused the zero and the ones, and that's why I was like, I don't get it, right? Like I was looking at this, for example, when I was looking at the one that's the number one that's dead in the middle, um, and and I just got confused about like cosineers because usually in these, and some of that is just I need to read better, but usually when people do these kind of island e things, zero is usually represents an water and one is represent land, and this problem flopped it around and kind of gave me some reading issues as a result, and I just kind of because I try to scan ahead, and that gave me a little thing, and that's why I skipped ahead to the fourth problem. um, and after that, I was like, oh, this is actually straightforward. You just kind of do leaky thing. I was trying to maybe do something clever with like some border check, but I just went for a depth of search essentially, and that was okay. And you just have to do some, and I kind of count this thing as not true if it could somehow reach the border, which, yeah, with a global variable. But yeah, and that's kind of essentially it. I mean, this is a very straightforward thought fill, so definitely something that I would recommend practicing on. But yeah, so overall, let's see where did I land up. Oh, I don't know how do I gain rank? Or like, how do I got faster? No, okay. Not sure how this works actually. Maybe someone had more penalty? Because I thought, oh, okay. Well, I mean, I would take it. 58th. Okay, I mean, I think I could have done faster, but I think I was okay. I mean, I'm still a little out of practice per se, so I'm not going to beat myself that much over it. Uh, and some of that was reading. I mean, how much I think if I look at it, I mean, I don't think I could have done that much faster, to be honest. Maybe like a couple of minutes. I still don't think I would have been that fast to be top 50. Over a easy-ish set. Um, Still amazing that that like the number one person beat two of my solutions can finish four bombs in two of my individual solutions. Okay, back to 78. That's what I thought. I don't know if there's some like weird because I feel like there's some like weird syncing issues with like Chinese servers and like people counting or not. But yeah, overall 78th. I mean, top 100. So happy with that. But yeah, and I'll see you next time. Oh, do I have anything meta? I thought I had something meta about it. Maybe I don't. Maybe that was it. Okay. Anyway, then I'll see y'all next time. Thank you. Yeah. So just here a quick segment at the end, and I forgot to do a retro maybe, but I think the retro is that yeah. I mean, I think looking back, there are a couple of points I could shave up minutes here and there. So definitely, I mean, it's good to know that you have places for improvement. You never want to be like, this is the best I can do, and my best is not good enough, or whatever. But here I also want to yeah, just look at some other problems, other very good people solving, and kind of see if I could learn from it. Cool. Oh, okay. This is actually smart. It just sums up the entire matrix. I mean, in terms of coding, anyway. It because I just do, which I'm okay. I mean, I'm only a minute behind, which I guess adds up if you're really top. But for me, it's okay. It shifts from 1 to 0 and then sums up the array. So that's smart. This one is the same as what I did, except for yeah. I mean, oh, actually, this is the smart way that I said that I mentioned earlier, where yeah, this will scale beyond way beyond oh, not this one, way beyond 50. So that's a great solution. So definitely recommend that. Let's see, reconstruct array is the second one with the greedy one, right? So I think everyone did essentially a version of the greedy. Um, I mean, he just actually ignored the zeros, but that's fine. Yeah, so same as I did, I think, in some ways. I mean, I don't think this one was. Ooh, oh, wow, he did it in under a minute, or he just maybe had a typo and then kind of jumped back and forth. I don't think he actually did it in a minute. That's even more insane. But yeah, oh yeah, everyone did some version of uh, greedy, which I'm not that surprised. And not otherwise, it's a very odd problem otherwise. And then the depth first search, yeah, standard depth first search. I mean, I think this is very doable, very smart. I mean, this is actually very similar to what I did, except for more abstraction, and he did it in 5 minutes and not 12 minutes. So, but almost a standard problem. Neo is very smart. And this is the breadth first search version, which is also a thing. Definitely a fan. I was debating it because I think you could, in that case, like do some maths on kind of getting the boundary type thing. And then the last one, what's the last one again? I mean, this is, I don't expect anything that funky about it. Everyone did it with the power set. This is slightly cuter, but I mean, this was actually even has a higher constant than my stuff. But so yeah. Overall, I mean, this one was people did it in like 4 minutes. I did it in 12 minutes. Well, it's not a whole 12 minutes because I went back and forth between a couple, 3 and 4 for a little bit. But even at the 25-minute mark, right, like that would have been only top 20, and I still have one problem to solve. So, but yeah, overall, generally an okay problem set. I'm happy with that. All right, see you next week.